Hi, welcome to the Calculus 1 lecture series. And we are in the unit number 3, applications of differentiation. We are the second part of the lecture number 20. And in this lecture, we talk about how the derivatives affect the shape of a graph. So on the video number 1, we talk about how do we use the first derivative to determine when a function is increasing and or decreasing. And also we talk about the first derivative test to determine a critical point could be a local maxima or local minima. So now in the second video, we're going to talk about how do we use the derivative to determine the concavities here. Okay, so now let's go ahead, go to our lecture notes here. Okay, so the first things here, let's take a look at the concavity test. So what is the concavity test here? So what is the concavities here? Okay, let's take a look before we write down here. So we know a concavity, for examples here. Okay, so here, this is what we did from the previous videos. That's fine. Okay, so here, the concavities here, right? So let's see, if this is my functions here, if I have a function like this, okay? So we know this is how do we define? We define this is a concave. Okay, so we will say, this one's here, we will say this is a concave up. So how do we decide the concave up? Okay, so let me see if you find the tangent lines here. So if this is my tangent line, this is my tangent line. Well, I'm doing terrible drawing here. Okay, so let's make sure I'm drawing good. Okay. All right, so here, let's do this graph again. Okay, so this is, we call this a concave up, all right? So the concave up, the way we define is if you find the tangent lines along here, so this is my tangent lines here, right, along this curve. So what happens here? So the tangent line, the concave up, that means your function, this green function, is above, right? It's above your tangent line here. All right. So the same way, if we say this one's here, if I find another one, and if this other one's here, if this is like for this function here, right? So let's say this function. So this function we called is concave down. That means if I find the tangent line here along this function here, right? So what did you see here? You see this green function is all below your tangent line. So this type of the function we call this a concave down here. Okay, so the concavity test is just like the increasing and decreasing tests here. So let's try to write it. So what is a concavity test? So the first, of course, we say if f of x is what? Is twice. That means the double integration is twice differentiable. Okay, so if f of x is twice differentiable on an interval I, okay? And then we say here, the first things here we said, if the f double prime x is greater than 0, so if double prime x is greater than 0 for all the x, then we will say here f is concave what? F is concave up. Okay. Okay, so then the second one's here we said if f double prime x is less than 0 for all the x, then what do we say here? Then we'll say f is what? F is a concave down here. Okay, so this is what we call this a concavity test. So remember, concave up, that means you all has what? Your function is above the tangent line. So like in here, you see here, right? So we know the tangent line, those are the red ones, right? So those are the red ones. And then you see here, from here, right? So the tangent line, the red one is the negative slope, then getting smoother, then make a turn and become a positive slope. And what is steeper and steeper. So that is why this one is greater than 0. That means the rate of the change of the first derivatives, right? So the first derivative is kind of like, you change that because the tangent line, the slope of the tangent line start to change. The rate of the change of the first derivative is going the positives, right? So that's why we say the f double prime positive here, so it's f is concave up. So the same way is here, right? The concave down, those are the first is the positive, right? Positive tangent line, the positive the slope, then go kind of like and then flatten out and then become negative, right? So the rate of change is going to decreasing, right? So it's become negative. So that's why we say this is a concave down here, okay? Now let's take a look let's take a look at these ones here. Make sure we understand how to define the concave up and the concave down. Okay, so let's take a look. F double prime x greater than 0. So this is f of x, right? For the 2 and the 4. Okay, between 2 and the 4 is here, right? Between 2 and the 4. So what is this one's here? So this is a concave up, right? Because if you put the tangent lines here, then this curve is going to be above the tangent lines here, right? So I said this one is what? This is true, right? So it's a concave up. Okay, so the next things here, they say the f double prime less than 0, -4 to -2. -4 is here, -2 to here. And then in here, so this is less than 0. This is correct? Let's see here. So this one's here, right? So this one, okay. So this one's here. The curve also is above the tangent line. So if above the tangent line, so what should it be? See here? So should it be +0, right? So this is false here. Okay, now let's take a look. F double prime 6 is equal to 0. So here, this is the F double prime 6 is here. Okay, so this function is f of x6. Okay, so you see here, right? So from here to here, this is what? This is a concave down. If a concave down, then what is this value going to be? It's going to be less than 0. So this is false here. Okay, so now let's take a look at f double prime 2. So for the double prime 2 here, so I know the 2 here from this curve here is a concave what? It's a concave up. If it's a concave up, then what happened here? The 2 is greater than 0. Is that true or false? That is true here, right? Okay, so now let me erase this. All right. So now the next question, let's say, f is a concave upward on the 0, 2. Concave upward on the 0, 2. That's true, right? Because from 0 to 2 is a concave up. All right, so this is what? This is true. So then they said f double prime x for x from the 4 to 8. 4 to 8 is here, right? So 4 to 8. So we know this is a concave what? Concave down. So concave down has to be less than 0. So this is true. Okay, so this is true. Okay, so then they said f prime 3 and f double prime 3 both will have to be positive. Let's take a look here. Okay, so the first thing here, 3 is here, right? So 3 is here, okay? This is F3. And then take a look here. From the concavity point, this is concave up. If concave up, then has to be positive. So this is okay, right? Now, I want to see the first derivative. So remember, what is the first derivative? It's the tangent lines, right? So let me see, here is my tangent to here. So this tangent line, so this is the increasing function. So increasing, then the f prime x is going to be greater than 0. Is that true or false? That's true. So this is okay. So both are okay. So I know this is true here. Okay. All right. Okay. So now let's take a look at another example to see this, what is we can get out from the f prime x and f double prime x here. Okay, so the first thing is here, the f prime x here, right? So the f prime x is the, okay, so this is the tangent lines here. So this is decreasing functions, right? So if you find the tangent lines like this, right? So this is a tangent line. So I know the tangent line is, go downward. So the f prime x has to be what? This is less than 0. It's just also like what we talked before. It's because this is a decreasing function. So f prime is less than 0. Okay, so how about the f double prime here? So what is this one here? This is the concave what? Concave up, right? Because this function is is all on the top of your tangent line. So it's a concave up. So what is here? This one is be greater than 0. Okay. Now here again. So this is the function, right? So this is increasing. If increasing, then what is here? We said the first derivative has to be what? Is positive. Then take a look at this ones here. This is a concave down because if you put the tangent line here, this function is below the tangent line. So it's a concave down. So what is a concave down? So it's f double prime x, it has to be less than 0 here. Okay, so now in here, let's take a look here. This function is a boom, 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 boom. It's all continuous and it's all increase, right? So it's increase function all the way. So I know this is the f prime x for what? All the x here. Okay, so now let's take a look at concavities here, right? Okay, concavities here, if you take a look here, this one from here to here is going bend downward. So this is concave down. And then you take a look at the concavity here is bend upward, right? So we know this is a what? This is a concave what? Concave up. And this is a what? Concave down. So I know f double prime x is less than 0 for what? For x less than 2. Then f double prime x greater than 0 for x what is greater than 2, right? Okay, so now let's take a look at this one. This one has a lot of things here, right? Let's take a look at first derivative, right? So first derivative, increasing. So boom, 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 here, dun, 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 increasing to here. And dun, 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 here, right? So this is increasing here. So this is increasing, and then this is increasing. And then what happened here? This is decreasing here, right? So I know f prime increasing is what? It's greater than 0. So where is that? From 0 to 1. And what? 3 to where? 3 to infinity here, right? Now maybe this is continuous down. So maybe instead of 0 to 1, so we can say is okay, so maybe we can say here maybe negative infinity to 1, right? Then the f prime x less than 0 is from the 1 to 3 because it's decreasing. Okay, so now let's take a look at the second derivative, the you know, like when it's going bend downward, when it's going to bend upward, right? Okay, so let's see then bend downward here, right? So it's go dun 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 here, right? So this is bend downward. Then where is bend upward? Start here is go up here, right? Okay, so now let's try to write that out or concavity. So bend, so this is the concave down, and then this is a concave up, right? So we will say f double prime x is greater than 0. So when the 2 to infinity and f prime x is less than 0, from where to where? Negative infinity to 2, right? So this is concave down, concave up. All right, okay. So now that is what you know that's what we talk about the concavities here. Okay, so then the next things here we want to talk about is the point of inflections. So what is the point of inflections here? So the point of inflections, we have the critical point, right? So this is the point of the inflections here. So the point of the inflection is the point where the concavity changes here. That means you can change from the concave up to concave down, or concave down to concave up. So like we did for this ones here, right? So this point here, so when x equal to 2, this is the point of the concavity because you change it from down to up. So the same way for these ones here, x equal to 2 is the point of the concavities here, right? So now in here, so you will see here, right? So the point of the concavity is like something like here. So you have a concave down and then you concave up, right? So then this point, we say this is the point of the inflections here. Then the same ways here, right? So the same way, if you have like something like this and like that, right? So then this point here, this is the point of the inflections here because the concavity change. This is concave down to concave up, concave down to concave up here. All right, so that's what is called the point of the inflection from the graph point of the view. So now how do you find it? Remember, we take the first derivative, right? We set the first derivative equal to 0, you find a critical point. So how do I find the point of the inflections here? So we have 2 ways to find it. So we set the second derivative equal to 0, then you solve for x. Or remember, just like a critical point, or the f double prime x is not defined. Okay, then solve for x here. So this will be possible, right? So the point of the inflection, how to find it, right? So how to find it, right? So this is, we say, how to find the point of the inflections. Just like we say how to find the critical point, okay? So now for the critical point, we have the first derivative test, right? So now for point of the inflections here, we're going to say that, okay, now how do we find the, where is the, the point, the second derivative equal to 0, and where is local max and local means here. Okay, now let's take a look at these ones here. Let's try to practice find the point of the inflections here. Okay, so the point of inflection, remember we say first, second derivative. So now let's take the first derivative. What is the first derivative here? 8 times 3, so this is 24 x to the square minus 4x cubed. Okay, then the f double prime x here, what is here is this is 48x minus 12 to the x to the square. Okay, so now just like we did before, let's try to factor the x out. So this is 12x, so this is a 4 minus x, right? 4 minus x. And then now, just like we said, we set it equal to 0, and then we find those here, right? So here, so we said this is equal to 0, this is equal to 0. So x equal to what? X equal to 0 and x equal to 4. Okay, so now just like we did for the find the critical point, okay, so in here you have a 0, you have a force here, right? So okay, you put into the second derivative, find anything less than 0, this number will be negative. Anything less than 0 is -1, so this will give you positive, right? So overall will give you negative. Okay, let me color code that. So this is this negative is from this 4 minus x term, and this negative is from this green term, and then overall here this is negatives here, right? Okay, now let's take a look at the next ones here. You choose anything between 0 and 4, you take it into the, so this is my double second derivative. Okay, so this will give you positive, right? So this one will give you the positives here. Okay, and then if you choose 1, 4 minus 1, so this one will give you positive. So overall will give you positives here. All right, so now let's see here, this is a positive. Okay, let me color code that. So this positive is from the 4 minus x term, and this positive is from the x terms here. Okay, now the next thing here is greatness, right? So this is a positive. All right, so this is a positive, and then the something greater than, so what is here? So if you choose 5 will be negatives, right? So let me color code that. So overall this will be negatives, right? So let me color code that. This one is from the x, and this one is from the 4 minus x term, and this is the overall. All right, so after that, now I can draw the pictures right now. Okay, so remember negative, right? So this is the double derivatives, right? So this is double derivative. So negatives here, right? So the negatives here. Okay, so it's a concave what? Concave down. So you draw pictures, concave down. And this is a concave up. And this is a concave down, right? So now you have to, oops, what happens here? Okay, so let's see here. And oh, okay, back here. All right, so I thought we lost it. Okay, so this is a concave down here. All right, so this is a concave down, and now you will see here. Okay, so now you will see we do have some inflection points here. Okay. Okay, so you know you're drawing concave down, concave up, and now you see, oh, okay, in here, I do have a concavity changes over here and the concavity change over here, right? So where is my inflection point? Both of them will be my inflection point. So the x equal to 0, then the y f of 0 is 0. This is one of my inflection point, so it's 0, 0, right? Or when x equal to 4, then the f of 4 will give me what? And the 19. So this is the 4, 19. So both of those are the inflection points because you see here, so you know the concavity changes, right? Okay, so now we're going to take a look at what is the, you know, we're going to take a look at what is the concavity, you know, what is the second derivative test here, okay? so let's take a look at the second derivative test. Okay, the second derivative test. Okay, so let's see here. We said, of course, we said if the f double prime x is the second derivative and is a continuous, okay, on AB, okay, and I have a number C is belong to AB, and we have f prime C equal to 0. That means it's my critical points here. All right. So remember the first derivative test, try to test the local max, local min. We need to see the first derivative increasing, decreasing, or decreasing, increasing here. Because we have the second derivative, the concavity test, so we know if the f double prime C is less than 0, because this is a second derivative, right? So if the second derivative less than 0, so okay, so we will say that this is a second derivative test. So we say f has a local maxima at C. Oh, why is that? So the reason why is that is because the, okay, so in here, if you take a look, if this is my C's, right? Because, take a look here, because they say the second derivative is less than 0. What that means? That means if it's less than 0, I'm going to have a concave up or concave down. I'm going to have a concave what? I have a concave down here. Right, so concave down. So because it's at the concave down here, right? So that's why at the C, what type here? I have a max here. So right, because that means the C in this here, I'm going to have a concave down because double the second derivative is less than 0 here. Okay, so the same way here we say if f double C is greater than 0, then we say f has a what? A local what? A local mean at the C here, right? So this one is similar. So in this one's here, they tell you like, you know, if this is the C's, right? So we said f double prime greater than 0. That means I'm having what? I'm having concave what? Concave up. So concave up, then this point here, this f double prime C has to be greater than 0. Because it's a concave up, every point here, the f double prime has to be greater than 0, right? So this is f double prime C has to be greater than 0. But because of f prime C is equal to 0, that means in here, you know, the tangent line here is a horizontal tangent line. That's why this one is a local mean here. Cool. Okay, so this is a really pretty good test here. Okay, so now let's take a look at how do we sketch the graph here. So this one is kind of interesting. So we kind of combined the first derivative, second derivative things, and let's see how good we understand this. Okay, so let's try to mark the point. F negative 1 equal to 4. So negative 1 and 4. So this is my first point. I need to passing through 0 to 2. This is my second point. 2 to 1. This is my third point. 3 to 0. This is my other points. Yeah. All right. And so now is f prime x is less than 0 for x is less than 3. That means from here all the way to here, my function has to be what? Has to be decreasing, right? Then after x greater than, so then this is greater than 0 after x greater than 3. That means from here to here, my function has to be increasing. Okay, so we know that. Okay, so now they said that f double prime x is less than 0 for x between 0 and 2. Okay, for 0 and 2 here, right? Between here from the 0 and 2, all right? So it says it has to be less than 0. What's less than 0 means here? That means what? It's a concave what? Concave down, right? Then from the 0, okay, so I'm sorry, so concave down is here. Okay, so this one's here. Okay, so this one is 0 to 2 has to be concave down. Then everywhere else will be concave up. Okay, so now let's try, all right? So 0 to 2 has to be concave down, right? So let me see here, my graph has to go like this, it's bend downward. Then everywhere else has to be concave up, right? So here, from here, I need to bend, so this is concave up, and then continue concave up. So here needs to be concave up. So what is here? Right, so this will be my graph. You see here from here, this one's here is always what, right? So this is the f prime. So function is always decreasing, decreasing, decreasing to here. Then after here, you know what happened here? Your function increasing, increasing here, right? Okay, so now let's take a look at our last problem. This one is really pretty good problem. It's combined everything together. Okay, so let's see here, right? So here, okay, so the first things here, let's say the where is increasing and the decreasing here. Okay, so we know the increasing and the decreasing, we have the first derivative, right? All right, so let's take a look. So the here, okay, so let's say the f prime x. All right, so the f prime x is 4/3, then the x 4/3 minus 1, so it's 1/3, right? Okay, and then plus a times what? And plus a times 1/3, okay? Now what is here? 1/3 minus 1 is negative 2/3. Okay, right? So now let's try to combine this a little bit. So this is the 4/3 of x to the 1/3, and plus this one is 3/8, and this is x to the what? 2/3 here. Okay, and now in order to be, find the increasing, decreasing, so I need to combine here. So I will say that here, this is 3x 2/3, all right, a common denominator. So if the common denominator is 3x 2/3, all right, so what happened to these terms here? If you want to put the 2/3 on the common denominator, so what is here? This would become what? X. Correct? Then I still have 4 in front, then plus the common denominator here. So this is already, so it's 8. So this is my first derivative here. All right, so for the first derivative, and then we know the first derivative, we want to find the increasing or decreasing. We find the critical points here, right? So let's see here. So that means f prime x equal to 0. F prime x is a fraction. The fraction equal to 0, that means only the 4x plus 8 equal to 0. So what is x here? X is negative 2, right? And also we say, hey, we need to find f prime x does not exist. Any point exist in the original domain and not exist in the first derivative? Oh, yes. Is x equal to what? X equal to 0 because in the denominator, but x equal to 0 does exist on the original, right? So, okay, so now let's do here. All right, so we do the here. So we said this is 0, this is, oh, sorry, here. Okay, so here, Okay, so we said this is -2, this is zeros, right? Okay, so now let's take a look where it's increasing and decreasing here, all right? So let's take a look. For everything is less than -2, right? Let's say -3. Okay, so the denominator, take a look, is x to the square over 3. So denominator is always positive. So let me color coding for you. So the denominator is this number, and this is the numerators here, right? Okay, so denominator is always positive. Now, if anything is less than -3, what I have is negative. So overall, that you have f prime x. So what is here? This is negative. Do you get that? Okay, so let me color code that for you so you know why I get these negatives, right? And then the overall here, this is a negatives here. Okay, so now the next one here is anything between -2 and 1. Okay, so like -1, so this will be a positive, right? So this will be a positive. The bottom is always a positive here. So overall is a positive. Okay, so now let's try to color code it for you. So bottom is always a positive. Then now this positive is from the numerator, and then the overall is a positive here. Okay, so now let's take a look at the next ones here. This is greater than, put anything, so it's a 1, so it's a positive, and a positive. So this is a positive, right? Okay, same way, let me color code for you. So okay, so this is overall is positive, and this positive is from the denominator, and this positive from the numerators here. Okay, now after that, I can start to draw. Okay, so this one here is negative. So what means negative? Decreasing, right? Then what is positive? Increasing, increasing. Correct? Okay, so now I can write it. So what is f increasing? So f increase, right, from the -2 to where? To infinity here, right? And where is f decrease here? F decrease is from the -infinity to -2 here. It's cool. All right. Okay, so now let's say find the local maxima or minima. Okay, so now if you take a look here, you say, oh, okay. So the local max and the local means here. So this is decreasing, the increasing. Oh, here's my what? That is my local what? Local means, right? Right, because it's going down and going up, right? So it's down and up. So your function go like here and then go up. So that's why you have a local mean. So you have a local mean at x equal to -2 here. Then if you plug into your function, so f of -2, you will get is the -7.6. So this is your local minima is -2 and -7.6. Okay, now the next ones here is where is the concavity, concave up or concave down here. Okay, so for here, and we're going to take the derivatives, right? So I'm going to take the second derivatives, right? So the first derivative we did is f prime x is equal to what here? The f prime x, this is equal to the 4x plus 8 over 3, the x to what? 2/3 here. Okay, so you can take the second derivative and you can use the quotient rule, or you can use the product rule. I mean the product rule, if you want to use the product rule, you can say this is a 4x plus 8 and 1/3, and then the x of the 2/3 here. Okay, so I assume so far, if you go to so far, you should be able to do the second derivatives here. So let's take a look. So the second derivative here, it will be, here is 4x minus what? 16. And this is 9x to the 5 over what? 5 over 3 here. Okay, so you can verify to see, my calculations here. Okay, so we know the inflection point could happen in the second derivative equal to 0. So the second derivative equal to 0 because it's a fractions, right? So that means the only numerator can equal to 0. So it's a 4x minus 16 equal to 0. So where is the x? X equal to 4. Good. Okay. Or or we said is the second derivative of what do not exist, right? So where the second derivative does not exist, still in the buttons, right? So that's why it's x equal to 0. But x equal to 0 does exist in the function, right? So those are the two potential inflection points. Okay, so now let's do the same thing like what we did for the increasing, decreasing. So now this is 0 and this is 4, right? So we are checking the second derivatives here. Okay, so I'm still double coding or have a fractions here. Okay, you choose anything less than 0, let's say -1. So what in here you have negative on the numerator. And because this is a 5 over 3, right? So what do you have here? If -1, so this one will be negative because 5/3, both of them are numbers, right? So it's a negative. So the overall, what is your second derivative will be positive here. Okay, so let me color code that so you will know which one is which, right? So if this is my numerator, so this numerator, and then this is the denominator, so this is the denominator is negative, and overall here this is a positive. Okay, so let's try one more from 0 to 4. Okay, so I choose 1. So if you choose 1, so for this one is negative. But here, this is extra 5 over 3. So this is what? It's positive. So what is the overall? Overall is negative. All right, so let's color code that. All right, so this one is the negative from the numerator, and this is the positive from the denominator, and the overall is what is negative here. All right, one more. Okay, so greater than 4. Okay, so let's say 5, so your numerator be positive, then bottom here, this is a positive, overall is a positive, right? Okay, let's try to do it one more time, the color code that, so you know where I get those number. So this is negative, right? And so the purple one is your denominator, and then here the overall is a positive. Okay, now let's try to draw to see we be able to get it. Okay, F double prime positive is what? Concave what? Concave up. What is this one? Concave down. And what is this one? Concave what? Concave up. All right, so do we have, where is the concave up, we say is the concave up will be where from the negative infinity to 0 and 4 to infinities, right? And concave down will be what? Will be from the 0 to 4, right? So do I have an inflection points here? Oh yeah, here, right here and here, right? So this is my inflection points here because those are the, those are the places they change the concavities here. So the inflection point right? So it's x equal to 0 and x equal to 4, right? So when x equal to 0, f of x equal to what? x3 0, x equal to 4, f of 4, you plug in into your original function is what is 19. Okay, so I have a 0, 0, and the 4, 19th here. All right. Okay, so now let's try to graph this one. This is the, if you know how to do that, that would be good. So then you got all the ideas, right? Okay, so now let's take a look here. So, all right, so we have a few things, right? So we know hey, this is local. So this is the local minima. So -2. So -2, let's say 1, 2. -2 and the negative. Okay, so this is our critical points here. Then 0, 0. Okay, so let me use different color maybe here. So this is one first point, then 0, 0. And then I have 4 and the 19. So it's 1, 2, 3, 4. And I have 19. So I said, whoa, 19 is somewhere here. Okay. And then it also tell me where is where is the increasing, decreasing here? Oh, that's the -2 is decreasing, then it's continue increasing here. Okay, so I know from here to here is decreasing, and from here to here is going to be increasing, right? And also from concavity point less than 0, oh, I'm going to have a concave up, and 0 to 4, I'm going to have here concave down and concave up again. Okay, so now combine those information. Let's try to do it. Concave up, right? And this is decreasing. So I know I can have a graph that's concave up, right? So it's something like that. Then after that, my going to be, okay, so this is from the 0 to, then here is a continue concave up, right? Then it's continue increasing now. And now in here, this is a concave down, but my x, so this is a concave down. So I'm going to go have this way, right? Concave down. And then this is a concave up. So I'm going to go like this. All right. So that is my graph. And so that is how is this section tell you how to use the derivatives to find the shape of the graph, right? So the concavity and the critical points. First derivative test and the second derivative test, right? So remember, concave up, right? So second derivative greater than 0, concave down, second derivative less than 0. F function increasing, first derivative greater than 0. F function decreasing, first derivative less than 0. Then don't forget, first derivative, you can find the critical points. You set first derivative equal to 0, or first derivative not exist, you can find a critical point. And then the same way, you set the second derivative equal to 0, and over the second derivative not exist. What you can find? You can find the inflection points. All right, that's it. Okay, and so that will be a very useful sections will help you to start to graph your functions and know the shape of your function. All right, that's it. And I guess I will talk to you in our next lectures here. Okay, bye.